Hey everyone, welcome back to the Deep Dive. We're diving into some pretty fascinating stuff today, fresh out of the AI world.
Yeah, this is exciting stuff.
You may have heard the buzz about DeepSeek AI and their brand new language model. It's called DeepSeek R1. And, well, we've got the research paper right here, deepseekr1.pdf.
That's right.
So we're going to break it down nice and easy.
Absolutely.
By the end of this, you'll be right up there with the AI experts on this one, trust me.
Yeah.
So think of this as your express lane to understanding a pretty major leap forward in the field.
Definitely a leap forward.
All right, so the paper goes deep, no pun intended, into how DeepSeek AI went about making their language models, smarter. And one of their big focuses was this, amping up the reasoning power of these models.
Yeah, reasoning, that's the key here.
And their secret sauce. Well, they went all in on reinforcement learning, or RL for short. It's this technique where you train AI using rewards and penalties, like a virtual pat on the back or a timeout,
Yeah.
And they did this in a couple of really interesting ways, starting from scratch in some cases,
Yeah.
and in others building on those classic supervised learning techniques.
Yeah.
So we're going to unpack all that good stuff today.
Okay.
Look at the cool innovations they came up with, how they trained these models, and then, of course, how DeepSeek R1 stacks up against the heavy hitters in the field, like the models from OpenAI,
Right.
the big names.
Yeah.
By the end, you'll have a solid grasp on what makes DeepSeek R1 so special and why everyone's talking about it.
And why it matters, yeah.
All right, so let's jump right in. The paper introduces two main models. We've got DeepSeek R10 and then just DeepSeek R1.
Okay.
Now, DeepSeek R10, that's where the story really begins.
Right.
And they took kind of an unusual route with this one.
Ah, interesting.
So instead of doing what everyone else does, starting with a massive amount of data that humans have already labeled,
Yeah.
like showing the model a bunch of correctly solved problems.
I mean, like a textbook almost.
Exactly. It's like a textbook for the AI.
Yeah.
It's called supervised fine-tuning, or SFT. They skipped that whole step and went straight to large-scale reinforcement learning.
So no hand-holding her, just straight into the deep end.
Straight into the deep end. Pretty bold move, wouldn't you say?
It is. You see, for a long time, everyone thought you absolutely needed that initial training on human-labeled data, that SFT, to even get to a point where you could use reinforcement learning effectively.
Yeah.
Especially for something as complex as reasoning. Like, you got to teach the AI the basics before it can solve the really tough problems, right?
Makes sense. So this DeepSeek R10 going directly to RL, it's like throwing a kid into a pool and saying, okay, figure out how to swim.
Exactly.
Yeah.
But here's the amazing thing. They actually pulled it off. DeepSeek R10, trained purely with RL, showed what the researchers call remarkable reasoning capabilities. And the crazy part is, these capabilities emerged all on their own.
Emerge naturally.
Yeah.
That's what really caught my eye in the paper, is like the AI was figuring things out by itself. So what kind of reasoning behaviors are we talking about here?
So the paper dives into a few interesting ones: self-verification, reflection, and these things called chain of thought reasoning processes.
Okay, yeah, the cut T. I remember seeing that. But what do those actually look like in practice?
Okay, let me try to paint a picture for you.
Perfect.
Imagine the model is working on a super difficult math problem.
Right.
Now, self-verification is like the model double-checking its work.
Yeah.
Like it's going back over its calculations or making sure its logic makes sense as it's solving the problem.
Makes sense.
And then there's reflection, which is even more interesting.
Yeah.
It's like the model is taking a step back and saying, hold on a second, am I even on the right track here?
Yeah.
And if it senses it's heading in the wrong direction, it might totally switch gears and try a different approach, almost like a human having a eureka moment. And finally, those long chain of thought or COTI processes,
Right.
those are basically the model showing its work step by step.
Oh, okay.
So it's not just spitting out an answer, it's laying out its entire reasoning process, just like a human expert would explain how they got to a solution.
That's really cool.
Yeah, it is.
And, what's even cooler is that these sophisticated reasoning behaviors, they weren't programmed in.
Right.
They just kind of popped up organically through the reward system the researchers designed. That's what's so fascinating about reinforcement learning, right?
It really is. It speaks to the power of RL, how it can lead to these unexpected, almost emergent abilities in AI.
Absolutely. And it's not just about these cool behaviors either. The performance metrics, the numbers, they're super impressive too.
Yeah, the performance is really what seals the deal.
The paper highlights a huge jump on the AME 2024 benchmark.
Yeah.
This is a really tough math competition for the brainiest high school students out there.
Not your average math test, that's for sure.
So the pass at one score, which basically tells you how often the model nails the right answer on the very first try.
Right.
It went from a measly 15.6% all the way up to a whopping 71.0% just through RL.
That's huge.
And then, get this, they used a technique called majority voting.
Okay.
And it actually ended up matching the performance of OpenAI's 010912 model at 86.7%.
Wow.
Now, for our listeners who might not live and breathe AI benchmarks,
right.
What does this kind of improvement actually tell us? What's the big deal here?
So this kind of jump, that's not just an incremental improvement. We're talking about a real breakthrough in the model's ability to grasp abstract reasoning, to solve complex problems. It's moving beyond just recognizing patterns, getting closer to actual understanding.
Yeah.
And that's a major hurdle we've been trying to clear in AI for a long time.
Yeah.
The AM, that's not about memorizing formulas. You need deep conceptual understanding. You got to be able to apply your knowledge in ways you haven't seen before. So seeing that massive increase in the pass at one score, that tells us this model's gotten a lot more reliable, a lot more accurate when tackling these really intricate problems.
Okay.
And to match the performance of OpenAI's 0100912,
Right.
which is already known for being great at reasoning, that really underlines the potential of DeepSeek's pure RL approach.
So it sounds like DeepSeek R10 was a pretty big win for reasoning, right?
Definitely a win, yeah.
But the paper does mention a couple of hiccups along the way. Stuff like poor readability and sometimes mixing languages in its output.
Yeah, interesting, right?
If the reasoning itself was so strong, why were these issues popping up?
That's a great question. So the thing is, while the model was becoming a reasoning whiz, the main focus during that RL training was all about getting the right answer.
Right.
The reward system, it basically said, hey, figure out the correct answer and make sure you use those think tags to show your work.
Yeah.
It wasn't really pushing for clear, human-friendly language. It wasn't punishing the model for mixing languages or being hard to understand.
Okay.
So the model could get to the right answer, but its thought process, it might be all over the place.
Yeah.
Maybe it's switching between languages. Maybe it's poorly organized, basically.
Yeah.
A mess for a human to try to follow.
Got it.
This highlighted a really important challenge. You can't just build an AI that's smart.
Right.
It's got to be user-friendly, too. It's got to be able to communicate effectively with humans, you know? And that brings us to DeepSeek R1.
Okay, yeah, before we get to DeepSeek R1, there was this one thing in the paper that I found super interesting. This aha moment the researchers observed during the DeepSeek R10 training.
That was fascinating.
They said it was like the model learned to rethink how it approached problems and to spend more time actually thinking things through.
Yeah.
Can you walk us through that a bit more?
So what happened was, at some point during the training, the researchers noticed this new behavior.
Right.
The model would start working on a problem, and then it would seem to just pause. Almost like it was saying, wait a minute, let me look at this again.
Wow.
And then it would revise its strategy, often coming up with a much better solution.
Okay.
There is a really cool example in Table 3 of the paper, where the model is solving a math equation, and it actually realizes it needs to go back and reevaluate its initial steps.
Interesting.
This was a huge insight for the researchers because it showed how RL, just by providing the right incentives, can lead to AI developing these really sophisticated problem-solving strategies.
Yeah.
And we're not just talking about memorizing facts or following rules.
Right.
This is about knowing when to rethink, when to change course. That's a really high-level cognitive skill.
Like the model wasn't just learning what to do, but how to think better.
Exactly. It's a bit mind-blowing, isn't it?
It is. It makes you wonder, is this a new form of thinking that we're witnessing?
Yeah.
Or is it just super complex pattern recognition that just looks like thinking?
It's a great question, and one we're still grappling with in the field.
So to go back to the reward system that guided all of this learning, it was mostly based on getting the right answer in the format of that reasoning process, right?
Exactly. For DeepSeek R10, they kept things pretty simple. They used rule-based rewards, mainly focused on accuracy.
Oh,
So correct answers got points, especially in areas like math and coding, where you can easily check if the answer is right or wrong.
Right.
And then they also had format rewards, which made sure the model neatly presented its reasoning steps within those think tags.
Okay.
But they specifically avoided using these fancy AI-driven reward systems called neural reward models at this stage.
Why is that?
Well, those can be tricky. They add another layer of complexity, and sometimes the model can get too smart for its own good.
Oh, yeah.
It can figure out how to game the system, how to get a high score without actually improving its reasoning abilities.
Like finding loopholes instead of actually solving the problem.
Exactly. We call that reward hacking.
So they decided to avoid that potential headache for now.
For now, yeah.
And they also used a pretty straightforward training template, right? The model first had to show its reasoning and then provide the final answer.
Yep, that's right. Keep it simple.
Okay, so we've seen DeepSeek R10 really showcase the power of pure RL for reasoning. But it did have those limitations.